Hey everybody, welcome back. This is Ms. McClellan here to go over IM2 5.2.4 with you. Today we're introducing the quadratic formula. In previous lessons, we developed a few methods for solving quadratics, and today we're going to do one more, and that's our learning goal. I'll write our learning goal in the first person. I will be able to, 1, solve quadratic equations using the quadratic formula. So 5-95 says, consider the equation x squared minus 4x minus 7. Before we get to using the quadratic formula, we're going to review our previous methods with parts A and B. Part A says to try to use the zero product property to factor x squared minus 4x minus 7 is equal to 0. So when I do that, I have A equals 1 because the number in front of x squared is 1, B is -4, and C is -7. And I'm going to do a diamond in a box. I start with my first and fourth box, so I have x squared right here and -7 right here. I know I need to multiply A and C to go to the top of my diamond because the diagonals of a box should multiply to the same thing, and I'm trying to figure out these two pieces. Okay, so -7, that's my first clue. And I know I need to add up to -4, because if I add the like terms, which would be here and here, I should get back to -4. All right. I can see that this is not going to work. Let me show you why. The factor pairs of -7 are 1 times -7 or -7 times 1. Neither factor pair adds to 4. 1 plus -7 does not equal 4. -7 plus 1, sorry, +7 minus 1 does not equal 4. What's happening is, since there are no factor pairs of -7 which add to -4, I can't solve this by factoring. Not solvable by factoring. All right. Let's see if we can solve it with completing the square. I mean, we've got more methods now. Let's use completing the square. So I want to find the x-intercepts of y equals x squared minus 4x minus 7. And to find those x-intercepts, I set y equal to 0. And I solve the resulting equation, 0 equals x squared minus 4x minus 7. Okay, well, to solve this, I'll take the equation, x squared minus 4x minus 7 equals 0. And I'll add 7 to both sides, which gets me x squared minus 4x equals 7. And I'm in good shape right now. I know how to divide 4 by 2. Okay, here we go. I'm setting up an area model. Okay, equals 7. So I've got x squared. I'm going to break my 4x in 2 even pieces, so -2x here and -2x here. And then I'm going to factor that. I've got x minus 2 and x minus 2. And in order to complete this square, I have to figure out what goes down here. And that's going to be -2 times -2, which is 4. Well, that involved adding 4 to the left-hand side of my equation, plus 4. And if I add 4 to the left-hand side of my equation, you better believe I'm going to add it to the right-hand side of my equation. Oops, 4. So I end up with x minus 2 squared, that's the square, equals 11. And now I have to solve this. Let me throw a Post-it on here because I want it to be tidy. So I'm going to solve this with a Post-it. X minus 2 squared equals 11. To solve this, I take the square root of both sides. That gets me x minus 2 equals the positive square root of 11. And x minus 2 equals the negative square root of 11. To solve each of these, I add 2 to both sides, which gets me x is 2 plus the square root of 11, or 2 minus the square root of 11. And those are my answers. X is 2 plus or minus the square root of 11. I like writing it in this compact format. However, you don't have to. I noticed that when I solve the equation, I have 2 solutions. I'll write it the long way. This is the same as saying 2 plus the square root of 11 or 2 minus the square root of 11. That plus or minus, everybody, it's important to know that it means I can express this as either compactly 2 plus or minus the square root of 11 or separately 2 minus the square root of 11. And you can write it however way you prefer. It doesn't, that's not why it's important. It's just, it's important to understand what other people are writing if they choose to write compactly. Anyway, therefore, I have 2 answers to the equation when I solve it. So there must be 2 corresponding x-intercepts. They are 2 plus the square root of 11, comma 0, and 2 minus the square root of 11, comma 0. That's not very clear because I want to be able to think of where that is in a number line. So let me get the approximate version. So the square root of 11 is about 3.31. So I could also write this as 5.31, comma 0 and 2 minus 3.31. Or negative 1.31, comma 0. And then it becomes more graphic, friendly. You can graph that. All right, so we've gone over 2 methods. We completed the square, and we applied the zero product property. The zero product property was a bust because this isn't solvable by factoring, but you can solve anything by completing the square, like no matter what, it's powerful. We connected the number of solutions to the number of x-intercepts there would be on a graph. As a reminder, the number of real solutions is the same as the number of intercepts on the graph. Now we're going to look at our very last method. It's called the quadratic formula. It's, I don't know, it's kind of cool. It actually comes from completing the square. At the very end of the lesson, we'll go over a proof that has to complete the square in general form. Using the parameters that we've used instead of numbers. And if you do this, what results is the quadratic formula. The quadratic formula is actually the general case of completing the square. All right, so let's get to it. The quadratic formula. One way to solve a quadratic equation is by using the quadratic formula. It's shown below. If you're using a printed copy from class, the printer didn't do a perfect job. The formula here is missing 2 symbols, a minus in front of the B and a minus in front of the 4AC. Because I know these video qualities aren't always that good, I'm going to write this again a little bit bigger. X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2a. And that's something that you need to actually memorize. And I'm including a link right here. I'll write it as a bit.ly so it's short. This link, if you go to it, wonderful student, will take you to a YouTube video, not by me. It's a recording of people singing the quadratic formula. It's a way to memorize it. And now I'm going to sing the quadratic formula to the tune of Papa's the Reaper. Here we go. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, and if you're in class in person, we're going to sing that like a million times. It's going to be great. That sounds fantastic. I will like it. I don't know if you will. Anyway, when a quadratic is written in standard form, meaning it looks like ax squared plus bx plus c equals 0, then a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. We've used that before. When we first learned how to factor, we always identified a, b, and c, and we did a times c on the top of the diamond and b on the bottom. At a, b, and c, the reason we emphasized it back then, instead of just talking about where things are, was because of the quadratic formula. Because we have to be able to find them quickly. So here we have x squared minus 4x minus 7 equals 0. And the question is, what are a, b, and c? Here we go. We have ax squared plus bx plus c equals 0, and we're trying to match that to this equation. X squared minus 4x minus 7 equals 0. Now the number in front of x squared is 1 if it's missing, because 1x squared is the same as saying x squared. Therefore, a is equal to 1. If you had a different number in front of x squared, a would be equal to that number. B corresponds to -4. So b is equal to -4 here. Please be careful. B is not -4x. It's just the number in front of x. The number in front of x is called a coefficient. B is the coefficient of x. And c is -7. All right, so we've identified a, b, and c. In a moment, we'll be plugging in these values to the quadratic equation, but first, a quick note. Now, the quadratic formula, the quadratic formula has 2 answers. Just like when you complete the square, you get 2 answers. It's like most of the time, if you're using the zero product property, you get 2 answers. The quadratic formula also has 2 answers. It's one equation, kind of. It actually is 2 equations in one. It comes from the plus or minus. So this plus or minus, I don't know if you can see in the video, but this is plus or minus, breaks the equation into 2 pieces. You have one version where you have x is equal to -b, first version, plus the square root of b squared minus 4ac all over 2a, and another where you have x is equal to -b, second version, minus square root of b squared minus 4ac all over 2a. The only time you don't get 2 answers is if b squared minus 4ac equals 0, because plus and minus 0 results in, I mean, plus or minus 0 is the same as plus 0. I don't know. Okay. Next page. So for part B of this problem, we're going to carefully substitute in a, b, and c from x squared minus 4x minus 7 equals 0. So I've got x squared minus 4x minus 7 equals 0, has a equals 1. Remember, the number in front of x is 1. B is -4. Remember not to include the x, it's just the coefficient of x, just the number in front, and c equals -7. We're going to carefully substitute this into our quadratic formula. I like to sing that song because otherwise I sort of can make the mistake of putting numbers where they don't belong. So I'm gonna rewrite this formula, but with blanks where all of the letters are, except for X. So I'm gonna put blanks for A, B, and C, and then I'm gonna fill them in after. So X is equal to negative. All right, negative, all right, blank plus or minus the square root, blank squared minus 4 blank, blank, all over 2 blank. Now I fill it in. So where all the B's are, I put B. So B is here, negative B, B squared, the negative 4 goes here as well. That's what B is. AC, so A here, all over 2 A is here, and C is negative 7. And this has two solutions because of the plus or minus. So this plus or minus breaks me into two pieces. And I'm going to write this in a simpler format. So negative 4, that becomes positive 4. This version will be plus. So this part I'm going to do in my calculator. All over 2A, so 2 times 1 is 2. And then this version will have 4 minus the square root of that big mess all over 2. Okay, calculator time. When you're using your calculator, you need to be really careful because, for example, I'm going to do the square root. I'm going to do negative 4 squared. If I use parentheses, negative 4 squared gives positive 16, which it should, because negative 4 times negative 4 is positive 16. But if I leave off the parentheses, it gives me negative 16. That's because here the calculator doesn't know that you're also asking it to square the negative part. If you're really careful, you leave those parentheses. Now I'm going to do the whole expression under the radical. So I've got negative 4, I'm being careful to use my parentheses, squared, minus 4. In parentheses, I'm writing the value for A. And in the parentheses, I'm also writing the value for C, AC. There it is. I press enter. I get 44. The number under the radical is 44. All right, now I am going to simplify. So I have 4 plus the square root of 44 all over 2. And I'm going to do that. 4 plus square root, I activate square root 44. Close parentheses. 10.63 about. .63 over 2. I leave the over 2 till last. The reason I'm leaving the over 2 till last is because if I press 4 plus square root of 44, and then I divide by 2, I get 7.31. But if I do 10.63 divided by 2, I get 5.31. That's because unless I do the whole top of my equation first on the calculator thinks that the only thing I'm dividing by 2 is the square root of 44. And I also want to make sure that I'm dividing 4 by 2 because 4 is also in the numerator of this fraction. Another option is to put 4 plus square root 44 all in one set of parentheses and then divide that by 2. You could also get 5.3. You have to be careful. Just have to be careful. I prefer to do the numerator first and then divide by 2 because then I'm going to be able to see my mistakes if I want to check my answers. I make a lot of mistakes. There are a lot of opportunities to make mistakes with these numbers. Okay, now I'm going to do 4 minus square root of 44. That's negative 2.63. Now I'm going to divide by 2. That's negative 1.31. About. So the last part of this question, do these solutions match the ones we got in question 5-95? And I mean, we want them to, because I'm solving the equation x squared minus 4x minus 7 equals 0. So the solutions I get should be the same no matter what method I use. And in 5-95, I used the method of completing the square, and I got 5.31, negative 1.31. I'm back here, and I use the method of the quadratic formula. Well, hey, I got the same answer. I have to get the same answer. Otherwise, the method doesn't work. All right, next problem. Here I have 5-97. Use the quadratic formula to solve the equations below for x, if possible. Check your solutions and put answers in decimal form and round to the nearest. We're doing 10. Okay. Yes. I encourage you to try these problems before you copy them down. It's up to you. Here I go. I always sing the song to myself because otherwise I make mistakes. X is equal to negative blank plus or minus the square root of blank squared minus 4 blank blank all over 2 blank. All right, I have A is 3, B is 7, C is 2. Negative B, 7 goes here. B squared, 7 goes here. 4AC, all right, so 3 is here. All over 2A, 3 is here. And C is the last one, it's right there. Okay, so this becomes 2 separate equations. I have negative 7 plus the square root of, I'm going to do that on my calculator in just a minute, all over 2 times 3 is 6, or negative 7 minus the square root, I'm going to do that on my calculator in just a second, all over 2 times 3 is 6. Okay, here we go. I'm going to be really careful to use my parentheses. So I have 7 squared, putting the 7 in parentheses. I just like to do the same thing every time. Hopefully that helps. Okay. 7 squared minus 4 times 3 times 2. This problem is the nicest version of this kind of equation you're ever going to get. It has all positive a, b, and c, and they're all numbers less than 10. Usually use the quadratic formula because the numbers are edging on disgusting. Anyway, this equals 25. So under the radical, I have 25 in both situations. This becomes, well, I know that the square root of 25 is 5, so I can say this is negative 7 plus 5 over 6, and negative 7 minus 5 over 6. This is negative 2/6, which is about equal to negative 0.3 and negative 12 over 6, which is exactly negative 2. So my solution answers are x is equal to negative 2, and x is approximately equal to negative 0.3. If you use equality for both of these at our level, it would be fine. You could just say x is equal to negative 2 comma negative 0.3. That's acceptable. There are situations where the approximation would be essential. Okay, next problem. All right. I have a is equal to 2, B is equal to -9, and C is equal to -35. This one gets harder if you are not super, super careful with your parentheses. You're going to start getting wrong answers now that B and C are negative. Okay, I have X is equal to negative blank plus or minus the square root of blank squared minus 4 blank blank all over 2 blank. I plug these in. I plug -9 in for B, negative B squared. I plug in 2 for A, 4AC over 2A. I plug in -35 for C. It's a mess, but whatever. Okay, this becomes 2 equations. Negative of -9 is +9. Plus, this version will be plus the square root of, I'm going to do that on my calculator in just a second, all over 2A, well, 2 times 2 is 4. Here I have 9, the negative version, so 9 minus the square root of, I'll do that on my calculator in a second, all over 2 times 2 is 4. Okay. I'm going to get this right because I'm going to be careful. So I'm squaring -9 squared. I just want to remind you, if you put parentheses around the -9, you'll get the answer right. If you just do -9 squared, you'll get the answer wrong. The calculator only knows to square -9 as -9 times -9 if you put that -9 in parentheses. Otherwise, it's doing -9 times +9, which will get you -81, which is not correct. Okay, anyway, here we go. -9 in parentheses squared minus 4. In parentheses, I put A, and in parentheses, I put C. Here we go. This becomes 361. Ooh. I don't know what that, I don't think that has a perfect square solution. Okay, now I'm going to do the numerator. 9 plus the square root of 361 equals 28. Oh, what's the square root of 361? 19. Ooh. I thought 361 was fine, but the square root of it is 19. That's cool. Anyway, so I have, for this side, I have 28 over 4. And on this side, I'm going to do 9 minus the square root of 361, which is -10 over 4. And that's going to get me X equals 28 divided by 4, which is 7. And -10 divided by 4, which is -2.5. Opposite, we're done. Next problem. Okay, now I have 8x squared plus 10x plus 3 equals 0. That's A is 8, B is 10, and C is 3. I put it in my quadratic formula. X is equal to negative blank plus or minus the square root of blank squared minus 4 blank blank all over 2 blank. Plug in B first. Let's plug in A first. Maybe that's what some of you are going to do. 4AC, so A is 8, so there. All over 2 blank A, so A is 8, and it goes like there. B squared. Negative B. Sorry, I put in just positive 10 here because the negative is taken care of from the formula. So 10. B squared, 10 goes there. 4AC, 3 is C, 3 goes there. This is 2 equations. I have -10 plus the square root of that mess all over 2 times 8 is 16. And I have -10 minus the square root of that mess all over 2 times 8, which is 16. And it goes right there. Let's figure out what that mess equals. Okay, so I have 10 squared minus 4 times 8 times 3. I always put it in parentheses. And it equals 4. Man, I thought that would give you a messier problem, but whatever. Square root of 4. So then, since I know the square root of 4, I'm not going to use my calculator for the next step. This is negative 10 plus 2 over 16 and negative 10 minus 2 over 16, which is negative 8 over 16. And this one is negative 12 over 16. Okay, that gets me x is equal to, I know that negative 8 over 16 is negative 0.5. I'm putting it in decimal form instead of writing my half just because that's what the prompt says. And negative 12 over 16 is less obvious. So let me do that. Negative 12 divided by 16, which is negative 0.75. I'm rounding to the nearest tenth, so that's negative 0.8. That's a negative sign. Make it more obvious. Negative 0.8. Those are my two x values for this equation. Next problem. I have x squared minus 5x plus 9. That gives me a is equal to 1, because when it doesn't show the number in front of x squared, that's what a is. B is equal to negative 5, that's the number in front of x, and c is equal to 9. There I go. X is equal to negative blank plus or minus the square root of blank squared minus 4 blank blank all over 2 blank. Okay, two equations. Oh, I forgot to plug in values in. Okay. Negative, then b goes here, negative 5. B squared, then negative 5 goes here. A, 4ac all over 2a, and c is, okay. So this becomes 5, first equation plus the square root of that mess, all over 2 times 1 is 2. 5 minus the square root of that mess, all over 2 times 1 is 2. Let's figure out what that mess equals. 5 negative 5 squared. I put the negative 5 in parentheses. I'm being careful. Minus 4 times 1 times 9, which is negative 11. And at this point, your calculator is going to do a little bit of rejection to you, because I want to find the numerator, right? I'll show you. 5 plus the square root of negative 11. Won't do it. No real answers. Gross. Just kidding. It's not gross. We know how to deal with this. This is 5 plus the square root of 11, I. 11 times I over 2. Which cannot be combined because these are not like terms. And 5 minus the square root of 11, I over 2. And that's going to be your answer. I want to make sure that I'm writing this in simplest form. And just as a reminder, square root of negative 11 is equal to square root of negative 1 times 11, which is the square root of 11. The square root of negative 1 times the square root of 11, which is I times the square root of 11, and we write that as the square root of 11 times I. That's because we changed that order right there because it's just manners. Usually write the number and then the imaginary I. And the reason that we have square root of negative 1 equaling I, well, that's by definition. By definition, the square root of negative 1 equals I. Okay. Let's summarize what we've done. So when you're solving an equation using the quadratic formula, you've got some steps to follow. First of all, this step you didn't actually have to do because it was done for you, but do you notice that all of these has ax squared plus bx plus c equals 0, ax squared plus bx plus c equals 0, blah, 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 equals 0 equals 0. You always have to make sure that your quadratic is set equal to 0. That's going to be step one, even though we didn't have to do it. Make sure you are working with an equation put it down once in a way that looks fine, and then I'll stop with it. In the form ax squared plus bx plus c is equal to 0, or 0 equals ax squared plus bx plus c. Either are fine. The point is that you need to have a standard form quadratic equals 0. These are symmetric and they're the same, these two. Okay, step 2, identify a, b, and c values. Figure out what a equals, b equals, c equals. Step 3, plug. Let's write substitute because it's more subtle. Substitute a, b, and c into the quadratic formula. Okay. Step 4, break into two equations and simplify. Step 5, write solution in whatever format is appropriate for the problem you are doing. And that could either be telling you what x equals, it could be writing x-intercepts, it could be answering the question, does this have x-intercepts? For example, the function for this one, this would correspond to y equals x squared minus 5x plus 9. And that function would have no x-intercepts because the quadratic formula returns numbers with imaginary components, meaning they're not real numbers. They're okay, at this point, we're done with the regular part of the notes, and we're going to prove the quadratic formula. You don't have to write anything for this proof. It should be attached to your notes, but I'm going to prove the quadratic formula by completing the square in the general case. So next page is going to be a proof of the quadratic formula, meaning I will be, actually, it's not even really a proof, it's more of a derivation. So the quadratic formula comes from completing the square. I'm going to complete the square for 0 equals x squared plus bx plus c, and then I'll use the result of that to complete the square for ax squared plus bx plus c. So we start with, and then I will finish with most proofs start with ax squared plus bx plus c, but I think that lacks clarity. Okay, so first I have this equal to 0. So when I complete the square, I always move my c term to the other side of the equal. So I have, instead of x squared plus bx plus c, I'll subtract c from both sides. And just as a personal preference, I like x squared plus bx to be written on the left-hand side of my equal sign. So I'm going to write it like that. So this is step 1. X squared plus bx plus blank is equal to negative c plus blank. And I'm going to complete that square. Here I have x squared. Here I have b over 2x. Here I have b over 2x, because I always break the b term in half. And then I'll find the outside. That's x, b over 2, and b over 2. And then this little piece here will be b over 2 squared, because I'm multiplying it by itself. So I have x squared plus bx plus b over 2 squared equals negative c plus b over 2 squared. I have to add it to both sides of my equation, as always. Then, remember, I'm trying to complete the square, so I'm going to write this in perfect square form. This is x plus b over 2 squared is equal to negative c plus, and I'll write this as b squared over 4, which is the same as b over 2 squared. Okay. So now that I've done that, I want to know what x equals. So number 2, solve for x. Well, when I solve this for x, I have the square root of x plus b over 2 squared. It's going to be square root of both sides. So negative c plus b squared over 4. And because I'm solving a quadratic, that gives me 2 solutions. So I'll rewrite that as x plus b over 2 is equal to plus or minus the square root of negative c plus b squared over 4. And then I subtract b over 2 from both sides. So I get x is equal to negative b over 2 plus or minus square root of negative c plus b squared over 4. Just 1 second. All right. That's everything that we need to do for the case where we have a is 1. But, that's not our final goal. We want something that looks like the quadratic formula. We want ax squared plus bx plus c. Ax squared plus bx. This is why I sing this song. Okay, anyway. Our end goal is to get to x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We are not there yet, but we can get there. We're close. Now we are going to consider the case when ax squared plus bx plus c equals 0. And it's honestly not that bad if you relate it back to what we've already done. So we're going to build off of this. 3. If we consider ax squared plus bx plus c equals 0, we can reduce this to that version, which is what you would do if you were actually completing the square. You would divide both sides of your equation by that a term. So here I'm going to multiply both sides of my equation by 1 over a, which gets me x squared, because I'll put it on as a fraction, because the a cancels, plus b over ax plus c over a equals 0, since 0 over a is still 0. All right, now I'm going to replace, I'm going to substitute b over a for all of my b values and c over a for all of my c values in my equation from step 2. So number 4, substitute b over a for b and c over a for C in step 2. So from step 2, I have X is equal to negative, but I'm not going to write B. I'm going to write B over A over 2 plus or minus, this is why I sing the song, square root, and then I have negative C by method of blank plus blank squared over 4. So where C was, I'm going to put in C over A, and where B was, I'm going to put in B over A. All right, we are almost done. The only difference between this and our goal is formatting. Okay, X is equal to, and this is negative B over 2A, same thing, plus or minus the square root of I'm going to put this part first. B squared over, over 4A squared. I squared the A and I moved it to the bottom because it's on the bottom of the fraction anyway. Minus C over A. This is our goal. This is where we're at. This part looking good. So this is the same as negative B over 2A plus or minus. Now I have a fraction and I want to combine it. So I need to have common denominators, plus or minus, meaning this one is going to need to be multiplied by 4A on top and bottom. So I have B squared minus 4AC, and all of this is now over 4A squared. Okay, I'm still going. This is still our goal. So now I have negative, this is equal to negative B over 2A plus or minus the square root of, I'm going to factor out 1 over 4A squared. 1 over 4A squared times B squared minus 4AC. This is equal to negative B over 2A plus or minus, this is a perfect square. So I'm going to make this 1 over, square root of 4 is 2, square root of A squared is A, 1 over 2A times the square root of B squared minus 4AC. And I'm going to write this as division, which is the same as negative B over 2A plus or minus square root of B squared minus 4AC over 2A, which is the same as negative B plus or minus the square root of B squared minus 4AC all over 2A. Yay! We're done. That's the quadratic formula. I hope you have a great day. End of the video. This is just one method. There's always others. If you're doing computer programming, this is how the computer solves your quadratic equations. Okay, have a great day. Bye.